The sun, and awe-inspiring. It's a vast, self-sustaining nuclear fusion reactor that dictates life as we know it. But today, we ask the unthinkable. What if humanity, with all our ingenuity and audacity, launched 100 million nuclear bombs at the sun? Would it explode in an apocalyptic chain reaction, collapse into oblivion, or simply shrug off our most extreme efforts like a mild inconvenience? Let's unravel this wild hypothetical and explore the immense forces that govern the universe. To understand the impact of our 100 million nuclear bombs, we must first understand the sun itself. Far from being just a glowing orb, the sun is a titanic sphere of plasma dominated by nuclear fusion. At its core, hydrogen atoms fuse into helium, releasing energy so vast it defies comprehension. This process churns out a mind-boggling 380 sextillion watts per second. That's 380 followed by 21 zeros. The sun's core burns at a staggering 27 million degrees Fahrenheit, while its surface temperature sits at a cool 10,000 degrees Fahrenheit. Its gravitational pull holds the entire solar system in place, and its energy sustains life on Earth. This is a system of near absolute stability, honed over 4.6 billion years of operation. It's also a colossal force, with a mass 330,000 times that of Earth and accounting for 99.86% of the solar system's total mass. But the sun isn't just defined by its sheer size and power. It's a dynamic entity constantly churning and shifting. Its surface roils with turbulent plasma flows, creating intricate magnetic fields that twist and snap, releasing solar flares and coronal mass ejections, CMEs, into space. These events, while dramatic, are just small eruptions in the context of the sun's immense energy. So how does our arsenal of 100 million nuclear bombs stack up against this cosmic titan? The bombs. Humanity's ultimate weapon. The Tsar Bomba, the most powerful nuclear weapon ever detonated, unleashed a devastating 50 megatons of TNT equivalent energy. This single explosion was 3,300 times more powerful than the bomb dropped on Hiroshima. Now multiply that by 100 million. We're talking about a total yield of 5 trillion tons of TNT, a scale beyond anything humanity could realistically achieve. It sounds monumental until we put it in the sun's context. The sun produces energy equivalent to 1 trillion Tsar bombas every second. Compared to the sun's output, our 100 million bombs are less than a fraction of a drop in the cosmic ocean. They simply cannot compare. The moment of impact, imagine the moment. 100 million nuclear bombs converge on the sun's surface, detonating in perfect unison. The resulting explosions release unimaginable energy, creating colossal shock waves and sending ripples through the sun's outer layers. But here's the reality. These shock waves wouldn't penetrate beyond the sun's outer plasma. The sun's massive energy output, driven by its internal nuclear fusion, renders it impervious to external attacks. The explosions would merely be absorbed into the sun's surface, creating temporary disturbances that would dissipate within moments. The sun wouldn't explode, collapse, or even flicker. It would carry on as if nothing had happened. But let's take a closer look at the potential mechanics of this impact. When nuclear bombs explode, they release intense heat, radiation, and shock waves. On Earth, these forces can devastate entire cities. On the sun, however, the temperatures in the bomb's fireballs, which peak at tens of millions of degrees Fahrenheit, are dwarfed by the sun's own core temperature of 27 million degrees. The sun's plasma would absorb and neutralize the energy almost instantaneously, making these explosions a negligible disturbance. Could the bombs trigger a chain reaction? Some might wonder, could these nuclear bombs destabilize the sun's core or trigger a runaway reaction? Theoretically, if the bomb's energy somehow reached the sun's core, where nuclear fusion occurs, it could disrupt the delicate balance between gravity and fusion. But in reality, this is an impossibility. The sun's core is shielded by thousands of miles of plasma at extreme temperatures and pressures. Even the combined energy of 100 million Tsar bombas wouldn't penetrate deeply enough to interfere with these processes. The sun's fusion is powered by its immense gravity, a force so strong it has kept the stellar engine running for billions of years. Human technology, no matter how advanced, cannot hope to rival this cosmic powerhouse. Additionally, the fusion reactions in the sun's core are fundamentally different from the fission reactions in our nuclear bombs. Fusion occurs at incredibly high pressures and temperatures, conditions that are not replicable outside the sun's core. This means our bombs wouldn't ignite additional fusion reactions, even if they somehow reach the core. While the sun would remain unscathed, the repercussions for Earth could be catastrophic. The explosions could disrupt the sun's magnetic field, triggering massive solar flares and coronal mass ejections, CMEs. These events release billions of tons of charged particles, which could travel toward Earth at incredible speeds. If a powerful CME were to strike Earth, it could induce a geomagnetic storm, overwhelming our planet's magnetic field and causing widespread damage to satellites, power grids, and electronics. This could result in massive blackouts, disabling communications, and plunging modern civilization into chaos for months, if not years. The economic and societal fallout would be immeasurable. For context, a massive solar storm in 1859, known as the Carrington event, disrupted telegraph systems worldwide and caused auroras visible as far south as the Caribbean. If a similar event occurred today, the damage to our interconnected technological infrastructure would be orders of magnitude worse. Put this in perspective. The sun is 330,000 times the mass of Earth and contains 99.86% of the total mass of the solar system. It's an unstoppable force that will continue burning for another 5 billion years before transitioning into a red giant and eventually a white dwarf. Our 100 million nuclear bombs, though terrifyingly powerful by human standards, are insignificant in the face of the sun's magnitude. This experiment is a humbling reminder of our place in the universe. The sun is not only untouchable, but also essential to our survival. But beyond its physical properties, the sun is also the subject of intense scientific research. Observatories and spacecraft, such as the Parker Solar Probe, are helping us unlock its secrets, from understanding the mechanisms behind solar flares to exploring the mysteries of its corona, which is inexplicably hotter than its surface. Respect the sun so, what would happen if we dropped 100 million nuclear bombs on the sun? Simply put, the sun would barely notice. The real danger lies in the potential side effects, such as solar flares and CMEs, which could devastate life on Earth. Instead of dreaming up ways to challenge the sun, we should focus on understanding and protecting it. The sun isn't just a giant ball of fire, it's the engine of life on Earth, the ultimate provider of energy, and a symbol of the universe's vast and untamable power. Let's respect it for what it is, a force of nature beyond comprehension. Thank you for joining us on this cosmic thought experiment. If you enjoyed this deep dive into the unimaginable, don't forget to like, share, and subscribe for more mind-expanding content. Until next time, stay curious.